Hey guys, welcome back to the Malware Analysis Bootcamp. In this video, we're going to be looking at analyzing the PE header, and we're just going to start off with understanding what information we're interested in when we're analyzing the PE header. So as mentioned in the previous video, the PE header contains information that the operating system requires to run the executable. Now this information is very useful as it gives us information about the origins of the malware or of the executable, and it also sheds some light on its functionality. And this can all be done, or this information can all be extracted through static analysis. Now when we talk about static analysis, we are primarily looking for information about the executable that again gives us a glimpse of its functionality and origin. And so far during the series, we've been able to get quite a bit of information from our sample that we were using. So let's take a look at what we're interested in finding, or what information is most important to us when analyzing the PE header. First of all, we're looking for the compiler stamp, which tells us when and sometimes where the malware was compiled. Now you may not get this information because again, malware authors or attackers usually know that analysts are going to be looking at this, so they try and throw them off by using different older dates, and this is something you'll come across. So again, if we are lucky enough to get the compiler stamp, or an accurate enough compiler stamp, that's a great information about how old the malware is and when it was last compiled, right? Secondly, we're trying to look for which subsystem is being used. Primarily, you will find many of the pieces of malware, or many of these malware samples using a GUI subsystem. So really not that important information, but it gives you an idea of what subsystem is being used by the executable and its functionality therefore. We move on to the sections, and in regards to the sections, we're looking for information in regards to whether or not the executable or the malware sample has been packed, and whether or not there are any inconsistent permissions for the various sections, and I'll be demonstrating this shortly. We finally look at the libraries and imports, which are extremely important because once we find out what libraries and imports are being used, we'll then understand some of the functionality of the malware, because we'll understand that these libraries are being used. And then if we take a look at the imports, we can see, all right, so these imports are being used, and from then we can deduce the functionality of the malware at a very basic level. However, all of the functionality will be put into test in dynamic analysis and behavioral analysis. So let's take a look at the tools we'll be using. For this video, we'll be using pestudio, and the reason being is pretty much one of the best and most efficient tools for static analysis, especially when it comes down to analyzing the PE header. So let's get started. Alright, so we are back in Flare VM, and we can get started with analyzing the PE header. So I'm just going to open up my samples folder, and we'll be using the standard sample that we've been using so far. The download link is in the description, but be aware when actually handling the malware. So I have the packed version and the unpacked version, and I'll be using them both in this video to demonstrate some very important aspects of static analysis. So I'm just going to drag this into pestudio so that we can get started straight away. So right over here, you can see that when we open up pestudio, we are given a beautiful tree here, or a very well designed and structured tree that contains all the various important categories or important pieces of information that will help us understand more about this malware and its functionality. So the first off, we have indicators. Now I'll get back to indicators in a second, and why it's a very important aspect of analysis, especially when using a tool like pestudio. It's a very important section here, and it's a great addition to this tool. So we have already talked about the DOS header and the DOS stub. The main pieces of information can be found within the file header, the optional header, the directories, which again give us the sections, the libraries, the imports. If you also have exports in your sample, you can also use them, resources and strings. So let's start off with the file header. Now, as I mentioned, we are primarily looking for the compiler stamp. Now, if you were to use a tool like CFF Explorer, so let me just open up the folder again, and I'll show you this right now. You can see that pestudio does it automatically converts this for us, in the sense that it gives us the actual compilation time or the compiler stamp. So let me just drag this into CFF Explorer. You can see that if we go to the file header here, the time date stamp is not converted for us, which that's primarily why I wanted to use PE Studio first. But again, CFF Explorer is also a great tool. However, I just wanted to explain why PE Studio, just does everything for you, and that's a great starting point as a beginner. So it gives us the compiler stamp right over here. So you can see Monday, October 17th, 4:48. 2016. So again, this is going to be 4:48 a.m. I believe. So that is when it was compiled. Now I do need to give you some important information about this. Now when dealing with the compilers, as I mentioned, sometimes attackers may use incorrect compiler stamps, or you may also find various other malware samples being automatically compiled. That'll give you an idea of the age of the malware, and of course, judging by this compiler stamp, I can safely assume that someone else has already analyzed this malware, or it is already detected, which means that my analysis can be made even easier. So, quite important information right over here. But again, you shouldn't go by this alone in regards to, getting a final assumption of the compiler stamp or when it was compiled. Next off, we have our optional header, which gives us important information like the subsystem, and as you can see immediately, it tells us in the brackets, just as it did for the file header, the date was given there, and in the optional header it gives us the subsystem immediately, which it tells us it's using a GUI, or the graphical user interface. Now you might be saying, why is this important? Well, again, it just gives us information in regards to what subsystem is being used, and given that information, we then can make the assumption that it can utilize the graphical user interface for a majority of its functionality. So again, now we know that it was compiled in 2016. It is a graphical user interface. It utilizes the GUI. And let's take a look at the directories now. So the directory now give us the sections, libraries, imports, exports, and also various things like the strings, but we've taken a look at strings. So starting off with the sections, you can see if you watched the previous video that everything is standard here. We have the text section, which again gives us our code, our data, and a relock. Now, don't worry about what the relock section is. You may encounter other sections of, with different malware samples. But what you're looking for primarily is for the standardized sections that are pretty much guaranteed to exist if this is a portable executable. The next thing you want to take a look at is the permissions. So right over here you have the permissions, and they're denoted by an X or a cross, right? So you can see that we are looking for the correct permissions for this section. So as I mentioned in the previous video, the text or the code section should be executable and should also be readable. So all of these sections here are readable, and in regards to the R data, you can see that it is initialized data. It is also readable, which is great. It's not writable or executable, which is also correct. As for the data, you can see that it is writable and it also is readable. So it's read and writable both, which is also correct as well. And for the relock section, you can see that we have, it is not writable nor is it executable, but it's still readable. So that is very interesting. It's something we'll be coming back to later on in this series. As for the libraries, so when we talk about libraries, we are essentially talking about the DLLs that are being used by the executable, and of course this gives us a basic overview of the functionality. So let me explain something over here. So let's start off with the sorting of these libraries and how PE Studio does it. So by default, you can sort out the libraries alphabetically. Then you have the blacklist option, which again is a great feature integrated in by PE Studio, which essentially blacklists the common DLLs or the dynamic link libraries that are most associated with malware or malicious intent. Now, they may not be malicious in nature, but they're just flagged as such. You have the imports, the amount of imports each DLL is using, or the functions that each is using. We'll get to the imports in a second. So let's take a look at, let me explain some of the most important ones. So kernel32.dll is something you will find used by almost all executables, because it essentially allows you to interact with the system. So kernel32.dll is pretty standard. advapi32.dll is primarily used for essentially modifying or interacting with the registry. So now we've figured out our first piece of functionality. So we understand, or we can see that indeed it is playing around with the registry. We'll confirm that in a second. We then have wininet.dll and the winsock32.dll, which are both used for socket connections and internet, or for establishing internet connections. So we have established just by looking at the libraries what functionality this malware has. So we can see it does interact with the internet, or it is sending data back, and we were able to establish that when we were talking about strings, because we did find the URL to the command and control center for this particular malware sample. So I'll be explaining all of these libraries as we move along. But if you want to research them on yourself, pestudio does it for you. You can right click, and for example, if I right click over here, you can copy these library names, and of course you can search for them in the Microsoft Developer network. I'll put the link in the description, and of course this is also extended into the import section here. So for example, let me just load this alphabetically. If I right click on the close handle import, you can see that it belongs to a group, the type, the blacklist, whether or not it's been blacklisted by pestudio in regards to its association with malicious intent, if you want to look at it that way. You then have the library that it belongs to, which is great. So we can look for advapi. For example, if we start off with that, we can see I was correct that the advapi DLL or library is responsible for interacting with the registry. So you can see registry close key, create key, enum value right over here. So we can see it is interacting with the registry, which again is quite dangerous and quite malicious. So what I was getting to, if you don't know what a particular import or a function is used for, you can right click on it, you can copy the import name, the library name, or you can search the Microsoft Developer Network, and that will give you an idea of its functionality. And from then, you can then sort of build a picture or a clearer understanding of the functionality of the malware. So let's try and analyze what's going on here. So we've already taken a look at the registry functionality. Let's take a look at some other imports here. So we can see immediately we have the create file mapping, which belong to kernel32.dll. They might not necessarily be malicious, but again we can see that this malware, it has the permissions or the ability to create a file, delete files. It can also exit processes. We can also find files, find next files. So it can interact with the file system. It can create a file, it can delete a file, it can find various files, it can get the file's attributes, the file size, which is, it's pretty much expected because this is a generic credential harvester. So again, its primary functionality should allow it to, you know, find files, create files, delete files, etc. It can also get system info, but again, that is pretty standard. Let's look for others here. It can interact with the processes or that currently exist. So it look for any 32-bit processes. It can interact with them. It can also open another process. This is something we'll be taking a look at. It can also read files. So the contents of files, which again is expected because it is supposed to steal credentials. Let's take a look at some of the other imports here. I remember seeing the winsock. Let's see if we can find it. Yeah, there we are. We can see we have the socket imports here. So there definitely is a connection being made through a socket. So we have the socket, set socket, send, receive, select the inet address. So it is definitely has the ability to connect to a particular address and send data. It also connects here. Internet crack URL and create URL. These are used to pass URL. So again, we already analyzed this when taking a look at the strings. We were able to see that we had a post request. So it is sending data back to a URL in the form of a post request. We'll be analyzing this as well. So again, we are finding out more about the functionality here. It also has the ability to make the computer sleep or to initialize a sleep as an event. Let's see. I won't be covering some of the more complicated pieces of functionality based on the imports because I want to keep it really simple at the moment. So there was one here, load library. That's the one I wanted to explain. So load library is something that is, it's an import that is quite popular with pieces of malware that dynamically load other libraries, which means that this might not be the entire extent of the functionality of the malware. So we've established a few things here. First of all, the malware can interact with the registry, so it can delete registry keys, it can modify, it can create new ones, possibly for persistence. Secondly, it can interact with the file system, it can find files, delete files, create files, check information about the files. It can also get the content of the files, which is where things get quite malicious, really. It can also get system information, as we already saw. It can get system information. And that's pretty much all that we've been able to find so far. Now, we also got other pieces of, or other hints, and those primarily came from the strings. So we're not going to fully analyze this right now. We'll be taking a look at it as we move along into our final lab for this section. This particular malware sample doesn't have any resources, so I'll be making an independent video covering this in the next video. Let's take a look at these strings. As we already saw, we can sort of navigate or we can browse through the strings that currently exist by their type. So we have ASCII and Unicode. We also have the hint or the blacklist availability here. So the blacklist gives us the most important strings here that possibly could have malicious intent. And immediately you can see that we have the various command and control centers here, or the URLs that I believe are command and control centers. So you can see that we have a very interesting domain here. So if we go back to the indicators is a great section that PE Studio has, and this gives us an idea of all. It gives us indicators in regards to things that we want to keep our eyes, we want to keep our eyes peeled for. So you can see, first of all, it tells us that the DOS stub is missing, so nothing important here. File references, yeah, nothing much there in terms of the severity, although it does give it a severity level of 1. So it gives it a severity level of 1 to 10, 1 being the highest severity, 10 being the lowest. And then we finally have the URLs that we were looking here, that we were looking at in a second. So it looks like this piece of malware connects back to these 3 command and control centers that 2 of which have a Russian that have Russian domains here, that are Russian domains, sorry. And that also can give us an idea of the malware's origin. So now that we have a basic understanding of where it might come from, we can now analyze this a little bit more when we talk about dynamic analysis and behavioral analysis. So the indicator section is a great place to start. Now, when I was talking about sections, I also made the point to also try and explain the impact of packers on the sections during analysis. So if I just drag this right over here, and let me just give it enough space here, and I'll open up the samples again, and I'll go to the packed version of this same sample, and I'll open this up in PE Studio. You can see that we'll give it a few seconds to load up here. So I'll just drag it right over here, and we'll give it a few seconds. So let me just go back into sections here. Now in sections, you can see a very big difference from when it is packed and when it isn't packed. So for example, in the packed version, the sections names have now been replaced by UPX 0, 1, and 2. Now I mentioned this in the previous video. Most of the packers usually have the prefix set as the section name, and this is the quickest way of analyzing or coming to the conclusion that this malware has been packed. Now you may not come across open source packers like UPX. That's a given. UPX is just an example I've been using. But again, this gives us an idea of the fact that this malware has been packed or it's been modified, and that we're not getting the entire or the full picture here. So let me just show you the impacts of packing on this. So if I go back to the indicators, you can see that this has now been changed quite a bit. So first of all, the great thing that PE Studio does, it already tells you that UPX has been blacklisted, which means you need to check this out and you need to analyze this a bit more. Well, let's take a look at the file header. The file header again gives us the compiler stamp, which again not important information here. If we take a look at the libraries, we now see that we have the same libraries that we were working with, nothing more. Again, it will give us the a basic idea of the functionality. But if we were to take a look at the imports, we now have such or so few imports that it'll be very hard to deduce the functionality, just by looking at the packed sample. So you can see, for example, we are extremely limited to the imports that we are able to see, in the fact that we only have things like send, a registry import here, or an import from the advapi32.dll library. So from this, we cannot deduce any real functionality. So I just wanted to use this to explain to you the impact that packers can have on the PE header as well. So that's pretty much all I wanted to cover in this video. Thank you very much for watching. If you have any questions or suggestions, let me know in the comment section or on my social networks, and I'll be seeing you in the next video.